Alright folks, welcome back. I had another request come in on how to determine the number of protons, neutrons, and electrons in the following species. So let's go ahead and get started. Let's look at problem A here. Problem A, what we have is we have chlorine. Now, on this chlorine, they're giving us this nucleic notation, Cl with a 35 and a 17. Now, remember that the 35 is our A number, which is our mass number. And if you remember by definition that our mass number is equal to the number of protons and neutrons, then this is actually quite helpful. Okay, so if you look at 17 here, 17 is the letter Z, which is our atomic number. And if you remember, atomic number is equal to the number of protons only. So we do know some things here. Okay, we know this. Okay, then we know the definitions of these numbers, so we know that the A value is equal to 35. We know that our Z value is equal to 17. Now that does not right off the bat tell us the number of neutrons or electrons, but it is helpful in telling us how many protons we have. We know that the number of protons, which I'll put a plus here for protons, is equal to 17. And the reason I know that is because basically Z is equal to the number of protons. Okay, now to get the number of neutrons, and I'll write it like this, an N with a little 0 for neutral, all I will do is I will take this 35 and subtract 17. If they're ever stacked like this, where you have your A value and your Z value, you can always just subtract them and you have the number of neutrons. Okay, so 35 minus 17 is 18. If you need to, you can use a calculator to do it quickly, and for simple reasons you can just do it in your head if you're able to do that. If not, then use a cheetalator. Okay, now to get the number of electrons, all that we need to do is look at the charge that is shown to us. Well, notice that there is no charge on this Cl. If there is no charge on the Cl, we can safely assume that the number of protons is equal to the number of electrons. So we have 17 protons and 17 electrons. So we're actually done with problem A. Now let's look at species B. If you really want to know what this is the isotope 35 chlorine here, and a lot of times you will see it written like this, Cl-35. Sometimes you'll see the number mentioned first. You'll see it written 35 dash then the word chlorine. Okay, so if you ever see a dash 35 or 35 chlorine, then that's what they're getting at. Okay, they're telling you that it's an isotope, meaning it has multiple versions of itself. Okay, anyway, sorry I had to go on a tangent there, but I wanted to address that. Okay, now B. Species B, we have a different isotope of chlorine. Okay, that's why I brought that up. Okay, now this one, its nucleic symbol is Cl with just a 37. Now, that's the number of protons and what? Neutrons. That's right, that's protons and neutrons for the mass number. Okay, but notice they did not tell us the number of protons. I know we can look over here and get that, but let's assume that we do not know the number of protons off the top of our head, or to the left or to the right of a previous problem. Let's say we have no clue. We need a periodic table to find that. So let's bring up our periodic table. Now if you look, chlorine is right here. Okay, notice that chlorine is in column 17, but look at its positioning and its order on the periodic table. Notice it's the 17th element, the 14th element, the 15th element, 16th, and the 17th element. Chlorine is the 17th element. Since it's the 17th element, it has 17 protons. Okay, and once again, they're telling us this thing has no charge. Okay, now all we need to do now is write down A is equal to 37. Okay, that's our mass number. Z is 17. Now, from this information, we're going to calculate the number of protons, the number of neutrons, and the number of electrons. Okay, so let's go ahead and get started. Notice here that we have an atomic number of 17. That's the number of protons. Now, to get the number of neutrons, what we're going to do is we're going to take the 37 and subtract 17 from it. So there's 37 minus 17, which equals 20. Okay, now that's the number of neutrons there. Okay, now to get the number of electrons, once again, there is no charge here. So what did we say earlier? Well, what did I say earlier? The number of protons would equal the number of, that's right, electron. So this number is 17 once again. Okay, we're done with B. Let's look at C. On C, we have the following. We have potassium, and its isotope version is 41. Now, do you know how many protons potassium has off the top of your head? I'm sorry, I don't. I'd have to look, in all honesty. So let's go ahead and get the periodic table and look at it. Potassium is right here. I'll zoom in a little bit so you can see that better. Notice that potassium is the 19th element on the periodic table, so it has how many protons? That's correct, it has 19 protons. So we need to write that number here. Okay. Now, what do we know? Well, we know our A value is 41, which is our mass number. We know our Z value is 19. And from these two numbers, we will calculate the number of protons, the number of neutrons, and the number of electrons. Okay. Now, we have 19 for the atomic number, so that means we have 19 protons. Now remember, to get the number of neutrons, we're going to subtract 41 minus 19. Okay. When we do that, we will get 22. Now, the reason why I am saying we will get 22 is because I made a mistake in the first video that I uploaded. One of my students caught it. I had written 21 here. Whoops, sorry. So thank you for the correction. I didn't mean to do that, but I made a mistake. Anyway, from this, we will then determine the number of electrons. Notice that there's 19 protons. There is no charge, so this thing is neutral. Therefore, the number of protons equals the number of electrons, and this count here will be 19. Now, on for problem D. Let's see. It's written a little bit different. Notice that it is written carbon 14. What they're asking you to do here is write the symbol carbon, and you have isotope 14. That is your mass number. It will be written up here at the top. Okay. Now, next thing that we need to find is how many protons carbon has. Well, if you will look on the periodic table, you will notice that carbon is the 6th element. Therefore, it has 6 protons. So we need to put a 6 here. Now, there is no charge because they told us it was, they told us it was not an ion, so we don't have to worry about a charge. So let's go ahead and fill in our values. Our A value, our mass number, is 14. Our Z number is 6. Okay. Our proton count, the number of protons that we will have, will be, let's see, 14, no, 6. That's right, 6. Now, the number of neutrons, now hopefully this time I will subtract correctly. To get the number of neutrons, it is 14 minus 6. Alright, that is 8. So let's put 8 here. Okay. And the number of electrons. All we need to know is that it's neutral, and if it's neutral, what do we know? We know that the number of protons is equal to the what? You guessed it, the number of electrons. So this should be a 6. Now let's talk about some that are not so easy and pleasant to deal with. Let's talk about ions. Okay, so we're going to do a couple problems down here. We're going to do, say we have chlorine, okay, and it has the -1 charge. And let's say that it also has the 35 for the mass number. You need to get the number of protons. I know you can look at the problem above and get that, but just a reminder, to get the number of protons, you notice that it's the 17th element. You make sure to put a 17 here. Okay. Now, let's fill in our values. Our value of A, which is our mass number, is 35. Our value of Z is our atomic number, which is the number of protons, and it tells us it's the 17th element on the periodic table. This should be a 17. Now, proton count. Our proton count will remain the same, which is 17. Because remember, if you change the proton count, you change the element. Now, let's get our neutron amount. Our neutron amount is once again achieved by taking our mass number and subtracting our atomic number. So you subtract those two numbers there and you get 18. Now time for the fun part, the electron count. Now remember that electrons are negative, okay? So this -1 actually means that we have one more electron. So if it was neutral, this element was neutral, it should have 17 electrons, which should equal the amount of protons. So the neutral point is 17. But look, I have a -1 charge. That means I've got one more electron. So I'm going to put not a -1 here, but a +1 there. The reason being is I've got one more electron. And remember, electrons are negative. So the total electron count here is actually 18. Okay? Now let's look at one where you have an ion that is positively charged. Let's assume that we have magnesium, and let's say that we have 26. Okay? Now, sorry my phone's ringing. Now, let's look at this. Oh, hold on, let me grab my phone and cancel the call. Okay? Now, if you notice, I've got 26 written here, but I need to write the charge here. So I'm going to put a +2 charge here. Now, we need to get the number of protons. To get the number of protons, you use the periodic table. You will find Mg. Notice that Mg is the 12th element. Okay, so you're going to put a 12 here. Okay. Now let's fill in the values that we know. Our A value is 26. Our Z value, which is our atomic number, is 12. Mass number is 26. Atomic number is 12. So our proton amount is 12, because that's our Z value. Our neutron amount is 26 minus 12, which is 14. Now comes time to get the electron count. The electron count is achieved by saying, well, if I did have a neutral element, it would have 12 electrons. But I've got a +2 charge. Remember, electrons are negative, so we had to lose 2 electrons. So we're going to put a -2 here. Now, just in case if you haven't seen the pattern, it's whatever the charge is, you write its opposite here. Okay, so 12 minus 2 is 10. So we have a 10 count for our electrons. So just remember that when something is positively charged, it has lost electrons. When it is negatively charged, it has gained electrons. Anyway guys, I hope this video was more helpful. Well, y'all have a great day.